partition. And so I got up on the table like this, and I was looking over the partition. It was wide. They stopped the conversation until I got down. They are serious about that. But I heard the injury statistics for DuPont worldwide. 12 injuries among DuPont employees, 12 injuries among non-DuPont employees on DuPont property. The most serious injury, a twisted ankle because someone stepped off a sidewalk wrong. I worked with US Steel for 9 months. 1 broken arm, 1 death. So DuPont takes its safety seriously. So don't do this if you work for DuPont. All right, so he is walking that way. There's friction between my foot and the paper. That's why it can move back and forth. So this foot's in the air. So as he's stepping, which way is the paper moving? Backwards. So, oh, occasionally I get vertigo too, so, you know. Extra stupid of me. But it's not a lab, so I can be stupid, right? Friction opposes the relative motion. What's actually moving is the foot against the ground. The foot wants to be moving back that way, and so friction opposes that foot moving that way. So friction's acting this way on that foot, exactly for the reasons that Jacob laid out. So F sub D, F sub D. Now there is a reason I have only one foot on the ground and the other one is in the air, is because there is a combination of it. The camera's just going to do theater of the mind here. So as you are walking, right now I'm pushing forward with my back foot, so friction's acting this way. My front foot lands, so if I were stepping on ice, my front foot would go forward. If you've never experienced this in ice, well, congrats. But, so there's friction acting back on my front foot and forwards on my back foot. As I get over, so as I start balancing on this foot, there's no friction acting on it, and then it switches. So friction on the feet, so the front foot will be this way, it'll be 0, it'll be that way. And it keeps alternating between your feet. The other reason why friction needs to be acting this way. If we look at the forces acting on it, we have normal force up. We have weight down. We have friction acting down and to the left. There has to be a net force in the direction of acceleration. This is why this was so critical. They're accelerating to the right, so there has to be some force acting to the right. Moving to the right is what tells us that the sled is moving that way and why friction's acting back. The acceleration to the right is why this has to be to the right, because we have no other forces that would do it. All right. Questions to hear before we talk about the boy? All right, so which way is friction acting on the sun? Again, we have 2 choices. Friction on sun from sled. Let's try it again. Who says friction acting on the boy is to the left? We got 1. Who says it's acting to the right? Madison? Did you vote?
I guess to the right.
Whatever. All right. Ian, way to be a voice. Way to stand up for it. Do you want to justify?
because I guess the best way I pictured it is like if the sled was a slick surface with very low friction,
right?
he's gonna wanna just fall off,
Yes.
so.
Which way will he fall off?
Oh, you're right, never mind. I was wrong.
And that's the trick there.
Good thing to think about it.
He would fall off, absolutely agree with that. So if, spectacular example here. Sled, the little boy. If it's frictionless, this thing is getting yanked out from underneath him. If it's frictionless, it's gonna go like that. The boy is going to fall off the back side of the sled. Friction opposes the desired relative motion. This is where the relative comes in handy. It's the relative motion to what he is touching. So the boy is touching the sled, so it's relative to the sled. So frictionless, he would stay where it is, and the sled would be pulled out from underneath him. Friction opposes that, so friction acts this way. And another rationale is assuming the boy is not falling off the sled. I should have stated that, but I hope it was understood. The boy is staying on the sled. Since he's accelerating to the right, there's got to be some force acting to the right. I have had students put friction in the opposite direction, and then they actually do think, they go, oh, wait a second, something's got to be going to the right, and so they just make up a force. Generally, applied force or something like that. Jedi force. All right, this is a test level problem. If you look at the old test, you'll see at some point I bring Jeeps into it, and et cetera, et cetera. Somebody standing on the back of a Jeep holding a rope. You got to work in the rope somehow. Do want to talk a little bit about the automobile. So any questions before we talk about a car and friction? Actually, I don't have to erase. So I basically have two objects here. I have car and I have road here. And so let's say car starts at rest. So V initial equals 0 meters per second. And it's going to accelerate to the right. So it starts at rest and it's about to start off. You know, it's at a traffic light, the light changes to green and it starts to move. Not in reverse. Assume no slipping between the tire and the ground, because we're about to get into some subtleties here. So for right now, assume no slipping between tires and ground. Do a checklist here. So what do we got? We have other?
No tension.
All right, Doug?
That's
All right, so that's what we don't have. Now, what do we have? Besides F and G, apparently.
Gravity,
All right, acting what way on what?
which is going down and the ground up.
Sorry, going down on what?
The which is acting down on the ground and the ground is acting up.
So it's down on the ground and up on the Jeep, is that what you said?
No, it's the other way around.
Okay. The preposition makes a difference. I'm pretty sure you said it's acting down on the ground. And it's possible I misheard, but. All right, so we have weight of vehicle. Did you call it a Jeep? Did I call it a Jeep?
We call it Jeep.
All right, we'll stick with that. Oh, in terms of subscripts, we ran into it with son and sled, both starting with the same letter. There are other ones where I have car and chair. Just please be aware that subscript C is fine for one of those, but not for both. So that's why I did B over there for boy. And you don't even have to, the letter doesn't even have to have anything to do with, the subscript does not have anything to do with the object. Some people just start with the letter A and then B and then C. Some will start with number 1, then 2, then 3, and that's fine. I try to have it some meaning to what it's connected to, that's just me. All right, so, gravitational force is done. All right, which way is friction acting? That way? I guess we're in a left-right situation again here. On Jeep from ground. Here we go. What is the friction force acting on the Jeep from the ground? All right, so who says, I guess I've been doing left first already, so left. You're changing your mind, or are you sticking with it? Who says right? Yes, I feel like you're on the fence here.
Yeah, right.
You. I think that was unanimous, right? So one of the 9 of you who voted that way. What's your justification for it being to the right?
I'm basing it off of, you said it's accelerating to the right, correct?
Yes, I did.
So the force is in, it is accelerating in that direction, so the force needs to be in that direction.
Okay, there has to be some force. It's not always friction, by the way, but in this case, okay, I'll buy it. What about in terms of the opposing desired motion? How does that fit?
Tires, it's rotating this way.
Yep. Because the tire is going around like that. So where the tire meets the road, the tire is trying to move that way, and friction hates that and sends it the other way. So friction is indeed to the right. Now, part of the reason I did this, wrote this up here, is I've got, how many tires do I have? Probably. How many friction forces do I need to draw to the right?
2 from this image.
All right, so it doesn't have to be 4. I feel of 2. Why 2? Why not 1?
Like, do you need?
Did you say the last thing?
Should it be 1 since it's all going in the right direction?
Okay. And? We make.
Yeah, I agree with him.
All right, Jake's got your back. The rest of them, I'm not sure. Yeah, you only need to draw it once. There's nothing wrong with drawing it twice. Well, this is what, is this a 4-wheel drive or 2-wheel drive? Front wheel, back wheel. So some more subtleties here. If it's 4-wheel drive, and there are a number of problems where I make it 4-wheel drive just to eliminate this. If it's 4-wheel drive, then there is friction acting to the front for both of them. If it's front-wheel drive, that means the engine is trying to turn the front tire, so the front tire's got this friction acting this way, but on the back tire, basically it would be drag, since there's nothing causing this tire to turn other than the road itself. If it's back wheel drive, then there's friction acting this way and then acting back that way on the front tires if it's back wheel, rear wheel drive. Now, I've tried to get around that. Sometimes I'm in the mood to see if students figure that out, and sometimes I'm not. When I'm not, I can make it 4-wheel drive, so all the tires are being turned. Or in one case, I made it tank tread, so that there really is just, well, I guess they're metal. What are tank treads made out of? Probably plastics at this point.
Definitely some type of metal.
What is it?
It's some type of metal.
Okay, so just the surface that's just gonna be sliding. All right, and so let's make it a 4-wheel drive. You only have to draw it once. If you draw it more than once, there's not a penalty to it. But if you did that, so if you get friction acting this way on both sets, on tests, I generally circle it, and that indicates I'm counting it as one thing. All right, and then the last,
On the ground in opposite direction.
if you've ever been stuck in gravel or something like that, and or mud, and suddenly you're shooting mud out the back, yeah, that's the force right there. That's sending mud out back as you dig yourself in deeper. All right, and the last force pair.
Normal force is up on the vehicle and down on the ground.
All right. I guess I didn't need a subscript there. No harm in it, but. If it's skidding to a stop, I think the one time I've had skidding to a stop, I had the wheels locked so that it was just classic, just sliding. But you sometimes have to think through and think, if it's frictionless, what's gonna happen? All right, questions where we actually solve a problem, work our way through facades. All right, let's take a 5-minute break, and as we set up for actually doing some math. That's right, there's the excitement. And someone